dy over dx if y equal to tan square cos x. So the solution to this problem is this. We want to differentiate this y with respect to x. So but then we can just apply some set of rules. Firstly, we'll make some assumption that u should be represented by that, so that we treat it like chain rule. So we say let u equal to cos x. Again, I will differentiate this u with respect to x. And the definition of cos is minus sign. Now, what is the next point? Here becomes y equals tan square u. Remember, I said that this should be represented with u or by u. So what is meant is y equal to tan square u. So this time we're going to differentiate this y with respect to u. And the simple way you can do this is this. Take this 2 down so that we have 2 tan u, and then differentiate tan. The differentiation of tan is sec square u. All right, that's simple, right? Good. So at this point, we'll apply the formula, and that is dy over dx equal to dy over du dot du over dx. Because you know this is a formula for function of a function, or call it chain rule, right? So this becomes dy over dx equal to dy over du is what? Dy over du is 2 tan u sec square u dot du over dx. Du over dx is minus sine x. Minus sine x. So what I would like for this sign to come to start off the process, because if everything there multiplied by minus sine x, the effect of this negative sign will just initialize this. So, but don't forget that your u was cos x. That's the assumption you've made. So now we want to reverse the process. Anywhere you see u, substitute it with cos x. So we have 2 tan, we have cos x sec square, we have again cos x and minus sine x. So let's take this out. So we have minus 2, we have sine x tan cos x sec square cos x. So this is the solution. This is the value for dy over dx. This is the solution. I hope you enjoyed this video. Please subscribe to my channel, like this video, and make sure you turn on the notification so that by the time I upload new video, you receive notification. Peace.